Hello students, welcome to Standard 10 Geometry class, Chapter 7, Coordinate Geometry, Revision Part 4. Children, these revision parts or revision lessons are very important. You go through all the revision lessons, okay? For your unit test point of view, lessons are very important. And in today's lesson, towards the end, I have given some practice examples and I want you all to solve those examples. Okay, so let us start with today's lesson. So children, if you remember, this sum we have solved in our previous lesson. Find the ratio in which the point P 3 upon 4, 5 upon 12 divides the line segment joining the point A 1 upon 2, 3 upon 2 and B 2, minus 5. We have solved this sum but by using k is to 1 method, means we have taken let P divides segment AB in the ratio k is to 1. Same sum can be solved by taking ratio m is to n, or you can take m1 is to m2. Okay, any of these notations you can use and then use the section formula, and the rest of the method is same. I just wanted to tell you that you can use any method whichever you find easy. Either you take ratio k is to 1 or m is to n or m1 is to m2, right? So if you please refer or solve this sum once again by taking m is to n ratio, right? And before taking next sum, I just wanted to remind you the properties of parallelogram, okay? While solving the examples, which all properties are required here. So the first property, opposite sides of a parallelogram are equal and parallel. And the second property is diagonals of a parallelogram bisect each other. Children, this property is very important while solving the sums. So here in the diagram, ABCD is a parallelogram and diagonals AC and BD, they intersect each other at point O, right? Because diagonals of parallelogram bisect each other, O is midpoint of diagonal AC as well as diagonal BD, right? Both the diagonals have same midpoint as O. So this property we are going to use in our next example. Here it is. Three vertices of a parallelogram taken in order are -1, 0, 3, 1 and 2, 2 respectively. Find the coordinates of fourth vertex, right? Out of four vertices, 3 are given to you and fourth one we have to find out. So let us give some name to this coordinate. Say A -1, 0, B 3, 1, C 2, 2 and the last one which we are going to find out, say D x, y, be the vertices of a parallelogram ABCD taken in order. So just now we have learned that property. Since the diagonals of a parallelogram bisect each other, therefore the coordinates of midpoint of AC is equal to the coordinates of midpoint of BD, right? So let me zoom this part, okay, so that you can see it properly. So you apply midpoint formula here for A and C. Here are A and C, these are coordinates, and what is midpoint formula? x1 plus x2 by 2, y1 plus y2 by 2, Similarly, midpoint of B and D. So apply that midpoint formula again on right hand side. Simplify. So you will get 1 upon 2 comma 1 on left hand side and 3 plus x upon 2 comma y plus 1 upon 2 on right hand side. Right. Now both the coordinates are the coordinates of midpoints. So same midpoint. So you equate x coordinate with x coordinate on right hand side and y coordinate with y coordinate on right hand side. So here x coordinate you equate. So you will get 3 plus x by 2 is equal to 1 by 2. 2 and 2 will get cancelled from the denominator. Further simplify, you will get value of x as minus 2. Similarly, right hand side, equate y coordinates. Simplify it, you will get value of y as 1. Okay, hence the coordinates of the fourth vertex, that is D, are minus 2 comma 1. Now next, prove that the points A 0 comma minus 1, B minus 2 comma 3, C 6 comma 7 and D 8 comma 3 are the vertices of a rectangle. So children, what are the conditions for any quadrilateral to be a rectangle? Yes, the opposite sides should be equal and the diagonals of a rectangle are also equal. So what we will do? One by one we will find out the lengths of all four sides of this quadrilateral, also the lengths of the diagonal, and then we'll compare and decide whether the given vertices are the vertices of a rectangle or not. So let us start. So first of all, length AB. So by using distance formula, that is x2 minus x1 the whole square plus y2 minus y1 the whole square. So coordinates are with you. Substitute here. You will get value of AB as 2 root 5. Similarly, calculate length BC. Apply distance formula. You will get BC as 4 root 5, CD as 2 root 5 and AD as 4 root 5. Right? So in this way we have calculated all four lengths. Children, you just compare these lengths. So you will find length AB is equal to length CD. Isn't it? AB and CD are the opposite sides of each other. Also, length BC is equal to length AD, the another pair of opposite sides. Now come to the diagonals. Diagonal AC. So the length of diagonal AC you calculate by using distance formula. So here we have got length AC as 10 unit. The other diagonal BD is also 10 units. So compare, both the pairs of opposite sides are equal and the diagonals are also equal. So opposite sides AB is equal to CD is equal to 2 root 5 and the other pair of opposite side BC is equal to AD is equal to 4 root 5 and diagonal AC is equal to BD equal to 10 units. Therefore, quadrilateral ABCD is a rectangle. Yes. Next, if the points A x comma 2, B minus 3 comma 4 and C 7 comma minus 5 are collinear, then find the value of x. Now what is the meaning of collinear? Collinear means if the points they lie on a single line, they are called collinear. So since the points are collinear, they do not occupy any area. So therefore area of triangle is 0 because they are not forming any triangle here. So area of triangle is 0. And children, you have learned this area of triangle by using the vertices of the triangle. So the formula is half into bracket x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 is equal to 0. Okay. So since the points are collinear, area of triangle is equal to 0. Now you have vertices A, B, C. Consider the coordinates as x1, y1, x2, y2, x3, y3. Substitute here in the formula. So you will get this step. Okay. Further simplified. So you will get x plus 63 is equal to 0. Therefore x is equal to minus 63. So in this way you can find out the value of unknown variable here. Next question. Find the area of the triangle whose vertices are A 2, 4, B minus 3, 7 and C minus 4, 5. Okay, here 3 vertices and the coordinates given. We have to find its area. So let us assign the coordinates of A as x1, y1, coordinates of B as x2, y2 and coordinates of C as x3, y3. Again apply the formula for area of triangle. Substitute the value of x1, y1, x2, y2, x3, y3 throughout. Then simplify it. So you will get the area of triangle is 6.5 square units. Right. So this is application based question. You just have to apply the formula, substitute the values and get the answer. And here are the practice questions. Question number 1. The fourth vertex D of a parallelogram ABCD whose 3 vertices are. So 3 vertices given. 3 vertices given here. So you consider fourth vertex as xy, and how we have done in the video lesson previously. You solve exactly the same way and guess the correct answer. Next question. Find the area of the triangle whose vertices are. So area formula is known to you. Consider this as x1, y1, second B as x2, y2, C as x3, y3. Substitute the value and straight away find the area of the triangle and tick the correct answer. Next, what is the midpoint of a line with end points minus 3, 4 and 10, minus 5? So midpoint formula, this is very easy, straightforward. One point is say A, other point is B. You just apply x1 plus x2 by 2, y1 plus y2 by 2 and get the coordinates of midpoint. Now last is point A minus 5, 6 is at a distance of. Means you have to find its distance from the origin. So distance of any point from the origin is given by the formula square root of x square plus y square. X is minus 5, y is 6. Substitute the value and tick the correct answer. So this is all about today's lesson. Children, prepare well, solve these questions and try to give your best in the forthcoming unit test. So all the very best. Do well. Thank you.